What's happening, everyone? It's nice, hot, and sticky outside. Definitely summertime. But that's good because there's a lot of work coming in and there's a lot of repair videos and diagnostic videos coming out in the near future. I got tons of stuff recorded. Today's no different. I want to go over mass airflow sensor diagnostics. Now, mass airflow sensors don't fail that often, and that's why I haven't really covered this in the past. But now that I'm seeing some older vehicles here in my shop, I'm able to go over exactly what to look for and show you a live example of a failed mass airflow sensor. Now, the most common code associated with a mass airflow sensor failure is nothing to do with the mass airflow sensor. It's usually a generalized code, like a lean code, P0171 and 174. And the reason why that is because the mass airflow sensor is the #1 input to the PCM for calculating fuel trims. And the fuel trims are what the PCM uses to go either negative or positive with the fuel trims to compensate for age of the vehicle, airflow inconsistencies, and overall drivability of the vehicle. It can sense the amount of air coming in, and therefore it can calculate the fuel quantity needed very accurately. Now, the problem with that is once the mass airflow sensor gets skewed, which isn't always caught by the PCM, it'll still take the mass airflow sensor's word for it. So it's going off of bad values coming from the mass airflow sensor, and all kinds of other concerns can come from that. Lean codes, overall drivability concerns, hesitation on takeoff, a vehicle that just runs like garbage in general, and even I've seen transmissions get burnt up in the past because the mass airflow sensor voltage is used as an overall load calculation for line pressure in the transmission. So you can see checking the mass airflow sensor is a very good place to start if you have any kind of lean codes on your Ford vehicle. Now today we're not just going to talk about it, we're actually going to show you a live example on the scan tool. So we're going to go over a few things on the engine real quick, and then we're going to go right into the scan tool. We're going to show you what to look for on your scan tool when you think your vehicle has this kind of concern. You can watch these different values from the old sensor and how the PCM reacts. And then you're going to see me put the new sensor in and how the PCM compensates just from that little bit of, that little 100 millivolts of voltage difference, and it's totally different. The engine runs better, takes off better, reaction time's better, and of course the fuel trims are back in spec. Okay, and we're back working on this 5.4 liter 2-valve engine. It has a concern where the fuel trims skyrocket at part throttle, so at idle they're just fine, but once you give it part throttle, 1500, 2000 RPM, they're at 30 plus, and it just kind of pegs out. It's kind of weird. Now, what can cause this is poor fuel quality. Well, that's been kind of ruled out. This thing's had about 6, 7, 8 tanks of fuel through it since the last time I've been here. And fuel pressure, of course. But I did a little test on the road that I do while I'm driving, kind of just gun it and see if the transmission shifts or not, and that can tell you a lot about fuel pressure. So that passed, and then you put a fuel pressure gauge on. I haven't drive it yet, but that's definitely no problem so far. What I found on it is the mass airflow sensor is actually reading something at key on engine off. So it's reading airflow at key on engine off, and therefore our idle reading is overestimating, and our part throttle and wide open throttle reading is underestimating. So it all makes sense. What I want to show you real quick is the old mass airflow sensor. You can see the wires in there. The sensing wires, they're really gnarled up in there from all those years of the dirt coming through there and the oil from that air hogs filter. Okay, and I've cleaned it with mass airflow sensor, but there's only so much that cleaner can do for these. Once that fine wire element in there gets damaged, it gets damaged. So I have not driven it yet. This is not conclusive, but I'll show you on the scan tool here what the new sensor from Ford is reading. Okay, see it's nice and clean, good to go, and what the old one is, and just how sensitive the vehicle is, the PCM, the calibration is to what this is reading. It'll take this thing's word over the O2 sensors any day. And you got to realize that when you're diagnosing these odd concerns like this. Okay guys, you can see here the mass airflow sensor, key on, engine off, is reading, well, I'm talking and moving air, so it's going up right now, but it's reading 0.14, 0.15, so that's like 150 millivolts, okay? Dead idle, no air going through it. This should say 0.01, 02, you know, something very, very minuscule where it's not going to affect the reading. What I found before I even took the mass airflow sensor off is it was sitting here just like this, 0.13. It's like 130 millivolts, 140, 150. Okay, so that's the old one. Now we're going to disconnect it. You're going to see a spike and a drop and all that stuff. Okay, and then we're going to connect a brand new one in from Ford. It's calibrated for the vehicle. We're going to see a spike, and then we're going to put it down, and we're going to watch it. Let it settle. Right there. See how it shows like that right there? Any mass airflow sensor should be right around this reading, 0.01, 0.02. And of course, it would be stable if it was inside the airstream there. Moving around a little bit of airflow, it's sensing like it should. Right there. That's the accurate reading. So from this point on, it's going to read at idle, at higher RPMs. It's going to read correctly, and of course, adjust the fuel trims accordingly. The fuel pressure test around here right now, we're reading 60 psi as soon as I turn the key on. I don't think there's going to be a fuel issue at all. I almost want to take it off before I even go on the ride because this is so off. This mass airflow sensor is so off. It's going to overestimate at idle, and then it's going to underestimate when we're driving. Okay, so this is how it's going to look. Here, I'm going to actually blow into it. This is a cool test you can do. And it should react as you see there each time I blow. Okay, so here is the truck at idle, hot idle, with the old mass airflow sensor in here. Now you can see it's like 0.9 or so. You have the AC on, so it's a little bit higher RPM, so our mass airflow readings be a little bit high. But look at this. Key off, key back on. No airflow, right? Turn the AC back off. Look right here. We have a mass airflow reading of 0.150 pretty much, 140 millivolts, and there's no air flowing through there. So already our mass airflow sensor reading is skewed. This is one of the first things you want to check. It should be around 0.01, 2, 3, preferably 0.01, like nothing. You're not reading no airflow past it, the engine's not running. Now also, after a while of this bad information, it will actually learn a lower barrel than what is specified for your area, and this barrel is all based on your elevation. So it can vary throughout the country, but for around here in Chicagoland, it should be around 158 to 160. So you have two things working against us so far. I'll show you exactly what it's doing. Now at idle here, okay, you can see because of that 0.14, we're already overestimating at idle, okay? So it thinks there's more air coming in than it's not, so it's giving it too much fuel, okay? So then the long-term fuel trims, and of course short-term once it gets running here, is going to adjust into the negative here, okay, at idle, okay, because it's actually miscalculating on the mass airflow sensor. So it's already bumped up well beyond what it should be for the airflow that's going across it. So it's going to overestimate at idle. As you can see here, it's pulling the fuel trims down because it's reacting to the O2 sensors. And once we go for a drive, you're going to see initially the short terms skyrocket 25, 26%, and then once it learns it, it'll do the same thing over here in the long terms, and that's the positive, which means we're running lean. Okay, right now I think it's running too rich, which it technically is, so it's adjusting the fuel trims negative. It's taking away fuel. So let's go for a drive.
and see what it does. Now, where this is worse, where this fuel calculation is off the most is part throttle, 2,500 RPMs or so. So we're cruising right now, 1,200 RPMs, and here we go. And you can see the fuel trims, the short-term fuel trims, which are going to react initially, they are just skyrocketing, okay? Look at that. You see them? They're off the charts almost. That's how far off the calculation is on there. Okay, now watch the RPM. You can see I'm driving, giving it part throttle, and look at the fuel trims. They're way off on there. Sometimes it's getting as high as 28% off on there. Now we're coasting. Bring it back up a little bit here. And when they get past 20 in general, is with the calibrations for the PCMR, the emissions calibrations, is when they're going to set the light for being too lean. And same thing for too rich. Okay, so if they're negative 20 something or they're positive 20 something, that's a trigger point. And that's why we're setting codes for lean codes on here. Now, as you can see, this is not a learned value yet, so it's still in the short-term fuel trims. It's reacting immediately, which means it's one of the inputs is skewed on here. It's not usually a fuel pressure issue. You can do a fuel pressure test, but I can already tell based on the vehicle's driving performance, especially under load, fuel is not an issue on here. Here we go. Look at the fuel trims, just skyrocket. Just underestimating what you're driving. It's not registering. So basically, when it's not registering, the actual airflow is coming in. More air is coming in than what it thinks, and therefore the O2 sensors react to that. They have the final say, and they are adjusting the fuel trims accordingly. So let's do a little bit of mid-throttle driving here. See the fuel trim? Whoa! And when you're at part throttle like that, 2,000 RPM higher, it's not a concern with engine vacuum leaks, because those show up at idle only. Anything above 2,000, 2,500 RPM is going to be a skewed sensor, okay, or dirty injectors not injecting enough, or your low fuel pressure to begin with. Any of those can cause the engine to go lean while driving. And in this case, it's the mass airflow sensor giving the wrong information. It's underestimating once you're driving. And you can see once I start driving and I get a little bit of throttle and get into a bit, and that airflow is, increases across there, and it's not registering. I mean, instantly it reacts and goes lean instantly. And that's another thing. If you're going to have low fuel pressure, you're generally going to not have enough at a wide open throttle position, not mid-throttle. So that's another indication that fuel pressure is fine also, in general.
Okay, so now with this mass airflow sensor reading this good now, this is perfect. This is what I'm used to seeing key on, engine off. This is the way it should be. I'm so confident in the repair that we're going to put the new mass airflow sensor on from Ford, and we're also going to, of course, change that air filter out to a Ford one that's a little more rigid and won't collapse like that. And I'm so confident that's going to fix it, I'm actually going to get rid of this fuel pressure tester before its engine ever gets hot. Great. Everything's back together and it's reading correctly. Key on, engine off. Now let's go ahead and reset that cam, and we'll start out fresh on here. That's very, very important. Especially when it comes to any kind of components, inputs to the PCM that decides what the fuel trims will be. So
So we'll clear that, turn the key off, turn it back on, let it sit for a second, and we can go over here and monitor this now. Okay, good to go. Let's start it up. Read nice. Now it's at a higher idle right now. You can go ahead and look at the RPM too if you guys want to see that. And we're going to let it learn the idle and base fuel trims, and then we'll go for a ride. RPM, where are you at? Right there. And let it learn. So you can see it's 1100 or so. So yeah, we're going to be at 1.3 volts. We're looking for it to be around 0.7, 0.9 on the mass airflow reading on this particular calibration for this vehicle when we're at high idle. So we'll see what it actually reads on there. I like to see them closer to 0.7 something. Most of them are. So we'll see what this one comes down to. Okay, I got a few more PIDs up on the screen here. What I can tell you is, wowee, this thing is definitely idling a lot better and just running a lot better in general. You can see how consistent the waveforms are for the O2 sensors. They were not like this before. It was way off. You can see we're idling down, we're getting down 1 volt, all that stuff, and of course, you know, our fuel trims at idle are hovering around 0. And it just keeps switching back and forth like it should. So everything looks great so far. We'll see on the drive once it learns the idle on here. Alright, here we go once again. Everything's reset. New air filter, new mass airflow sensor, and we're driving along. Fuel trims are immaculate. Good power, good idle, good drivability. Now what we're also looking for is for that barrel up top there to update, which it already did upon that mid-throttle takeoff right there. And it should continually update up until the correct barrel for your region, your area of the United States. And around here, it should be around 157 or so. Back in Illinois, pretty much at sea level, so I like to see 158, almost 159. The newer vehicles that have brand new mass airflow sensors and more accurate, they're closer to 160 hertz in Chicagoland. So that right there gets you the most accurate reading based on your elevation and air density. So we'll just drive around and we'll learn the fuel trims at the different throttle ranges and airflow range on there, and it'll hone in perfectly for this particular vehicle and the vehicle's age, more importantly. As the vehicle's age, stuff starts leaking, stuff starts not working so well, and that's part of what the adaptive fuel trims do. They accommodate for all of that. So that's what it's doing right now.
Now there's one other thing I want to talk about. Now your mass airflow sensor, yeah, if you have any kind of concern with it, the first thing you do is clean it. I'll link to the mass airflow sensor cleaner down below and the video on how to clean your mass airflow sensor properly without damaging it. Now, the other thing about that is that a lot of guys, I've had technicians come and ask me for help. The smallest bit of spider webs, insects, I've seen wings from insects get in that hot sensing element in there and cause lean codes because the airflow calculation is then off. It's literally air going past this hot sensing element, and it has to go past it and over it to sense the amount of air that's coming into the engine. If it's blocked in any way, it's going to be off. So you can have contamination like oil and dirt, or you can have, you know, not too common, but it happens, you know, a little piece of a leaf, a bug wing, insect, spider webs, all kinds of stuff on there that can cause it to be off. That's all for now. Until next time, keep in contact with us on Twitter, Instagram, and Facebook. With Facebook being the best place to contact me about your own personal vehicle and how to diagnose it. Hope to see you there.